These are the notes for sine and cosine ratios. Yesterday we did the tangent ratio. We kind of discovered where it came from. We talked about what the meaning is. And this is the same idea. It's just a different set of sides in the right triangle that we are using. So each angle has a unique ratio that goes with it depending on which two sides you choose. So the sine is the ratio of the opposite leg to the hypotenuse. The cosine is the ratio of the adjacent leg to the hypotenuse, all depending on which angle you choose. In geometry, we're not going to do anything from the right angle. Looking at sine, cosine, tangent of right angles and other angles is going to come up in a later class in probably Algebra 2 or trigonometry. The most popular way to remember which trig function goes with which ratio is SOHCAHTOA. Sine is opposite to hypotenuse, cosine is adjacent to hypotenuse, and tangent is opposite to adjacent. So when we come over here and I ask for the sine of S, what I am asking for is what is the ratio of the opposite side to the hypotenuse based on angle S. So I go to angle S, opposite angle S is 63. The hypotenuse is 65. So the sine of S is 63 over 65. So why don't you push pause and see if you can do the sine of R, the cosine of S, and the cosine of R. All right, so here they are. Now from R, opposite of R is 16. The hypotenuse remains 65. Cosine of S, so I start at S, adjacent to S, the adjacent leg is 16. The hypotenuse is 65. For angle R, the adjacent leg is 63. The hypotenuse is 65. All right, over here, we're going to use sine and cosine to find missing sides. So as I look at this triangle, I can't use Pythagorean theorem. I don't know two sides. I need at least two sides to do Pythagorean theorem. It's not a special right triangle because I can see that's a 67, so it's not a 45, 45, 90 or a 30, 60, 90. So to find x, I'm going to use the 67-degree angle, and I'm going to look and say, okay, what is x to 67? It is opposite of the 67-degree angle, and I know the hypotenuse. So I'm looking for a trig function that uses opposite and hypotenuse, and the answer to that would be sine. So the sine of 67 equals x, the opposite side, over the hypotenuse. Then I'm going to multiply both sides by 120, type it in my calculator just like that, and I get that x is 110.5. For finding side y is adjacent to 67. So I have my adjacent side, and I'm going to use that hypotenuse. I'm not going to use this side I found over here because I know I rounded this side, and every time I start to use rounded numbers, I'm getting farther and farther away from the most accurate answer. So I'm going to use adjacent and hypotenuse, so that means I'm going to use cosine. Cosine of 67 equals y, the adjacent leg, over 120. Multiply both sides by 120, and then you get your answer. So what I'd like you to do is please push pause and try this problem on your own. Okay, and these are the answers for those problems. Look at your work if you didn't get those answers, and you can send me some questions too if needed. All right, the sine of the angle is 12 over 13. So now I know the ratio, but I want to know the angle. Inverse is what gives angles. Inverse gives angles. So the inverse sine of 12 over 13. So now I'm saying, calculator, here's my ratio this time. Can you give me the angle that matches this ratio? And you'll type it in just like that, and you'll get 67 degrees. Okay, for this one, I know the ratio of opposite to adjacent leg is 5 over 12. Well, there's only one angle that has this ratio when you do opposite to adjacent leg. So we're going to do inverse of tangent. Inverse gives you angles. So inverse tangent, because that's tangent, of 5 over 12, and you get about 22.6 degrees. Over here, it's the exact same idea. You're just plugging in a decimal instead of a fraction. So what I would encourage you to do is push pause and try to do these on your own. All right, you can see the answers here, and this is exactly what I typed in. So again, this specific ratio matches to only one angle. If you want an angle, you use inverse. All right, over here, it's the same idea. So n 18 is opposite of n, and I have the hypotenuse. So opposite hypotenuse, okay? Opposite hypotenuse means I want sine. So I did inverse sine of 18 over 30. In this problem, please look at the 22 and the 40. What kinds of sides are they? Are they opposite, adjacent, or hypotenuse? This is adjacent, this is hypotenuse, so I want cosine. So why don't you try that one on your own and then come back. All right, and there's your answer for that one. The next part we're going to look at, it's not really 8.5 in your book, is angle of depression and elevation. Notice that both of these have a horizontal side. Angles of depression and elevation always have a horizontal side. So angle of elevation is from a horizontal upward. If you were looking up to see something, you would elevate your eyes to be able to see that. An angle of depression is horizontal down. If you were looking out and then you had to look down to see something, you've moved your eyes a certain number of degrees, which is called the angle of depression. So over here we have angles 1, 2, 3, and 4. And what I'd like you to do is push pause and identify, are they angles of elevation or angles of depression? So please push pause now. All right. Angle of depression, horizontal down. Angle of elevation, it's a horizontal upward. Angle of depression, horizontal down. Angle of elevation from the horizontal, it angles up. All right. I have all the answers here. So skiing on a mountain with an altitude of 1,200 feet, the angle of depression is 21 degrees. So the horizontal down is 21. Well, if this is 21, so is this, because these are alternate interior angles. We can prove these lines are parallel. So now focus on this right triangle right here. So from the 21 degree angle, I have the opposite side is 1,200. I don't know the hypotenuse. That's the part I'm looking for. So opposite hypotenuse means I'm using sine. So sine of 21 equals 1,200 over x. I multiplied both sides by x, then divided both sides by the sine of 21. And that's how I got this answer here. And again, remember, you can pause and rewind at any point. All right, a surveyor stands 200 feet from a building. It should say from, not form. So distance from the building is 200 feet to measure its height with a 5-foot tall theodolite. I will explain what that is later, or you can Google it. Surveyors often use that. So we know that this is being measured from something 5 feet tall. The angle of elevation is 35 degrees. So the angle of elevation is horizontal up. Starting at the horizontal and moving upward. So I am looking for this. X is opposite 35, 200 is adjacent. Opposite adjacent is tangent. So you can see I solved for that here, but then I had to add in that 5 feet. So that's where the 145 feet come from. Okay, similar idea here. We have a person and a building. Angle of elevation is 58 degrees. I'm looking for the opposite. I have the adjacent. Okay, so I can use tangent. And then when I solve that, remember that only gave me this part of the right triangle. To get the whole building, I have to add the 1.5 meters from the person standing there. For the last one, the sun's angle of elevation is 38 degrees. So the horizontal up is 38 degrees. And this is kind of that same idea if you've ever seen a clock that they use based on the sun, a sundial. This is that idea that the angle of elevation of the sun changes depending on the time of day. So we know that these two angles are equal. If you look, those are corresponding angles. So those are equal. The shadow, which is on the ground, is 45 meters long. And I'm looking for the height of the building. So from 38, I need an opposite. I have an adjacent. Opposite adjacent is tangent. So I'm going to have that here, tangent of 38. I solve, and I get the height of the building. So